Hello, my dear student. I'm Saktwala from Educare TZ. I will be with you in physics for Form 5. And today, my dear student, we are going to proceed with our discussion on our topic of rotation of rigid boards. For our subtopic of talk of a rotating rigid boards. Now, today we are trying to proceed with our discussion here. So, welcome, my dear student, to continue where we ended on the last session. But before we proceed here, let us remember where we ended on the last session, so as to make a link between the previous lesson and also with this lesson. Now we can say that on the last session we tried to see the concept about the torque. We tried to define the meaning of the torque, and after that we looked at the formula how that we can apply so as to find the torque. That is what we tried to see on the last session. So for our today's session here, we are going to consider a rigid body rotating about an axis. Let us proceed where we ended. And we have been told that let us consider that imagine we have the rigid body, and that rigid body rotating about an axis. Now PO with an angular velocity, this one with an angular velocity we know it is a symbol. Now, in which every particle of the body rotates with the same angular velocity. Now, imagine that we have the rigid body, and that rigid body, my dear student, are trying to rotate on it is an axis, but it rotates on the axis of PO, while the angular velocity is the same. Now, how can we get the torque? That is what we are going to see on our figure number 20 for our first topic here. So, my dear student, this is a rigid body that indicates the rotation and the torque. This gives us the rotation and also the torque. So, once we observe here, O is the center and also P, OP is the axis of rotation. This indicates the angular velocity as we try to observe here. Kwa hiyo hapa ni angular velocity, na hii OP ni axis of rotation. So the distance, we have the particles. We have the first particle and also we have the second particle as we try to see here. But most of those particles, they have been located at a certain distance R. We have R1 for M1, and we have M1 for the particle A, which is located at a distance R1. And also we have this OB. And at OB here, this particle at the point B is allocated with containing the mass M2, and also is allocated at the distance R2 as we try to demonstrate here. So this OP here indicated the axis of rotation. We see how this rigid body rotates on it is an axis. It try to rotate on an axis and give us the relationship between the rotation and also the torque. That is what we try to demonstrate here. So let particle A and B with mass 1 and M2 rotate with an angular velocity W. Imagine that this figure as we have tried. The particle containing M1 and also the particle that contain M2 are trying to rotate with an angular velocity here, which is represented by W. Also, also from the new second law of motion, the net force acting on A can be expressed as this one. Kwa tukiliko sasa kutoka kwa Newton second law anavyosema. Newton second law say that from the Newton second law that we have tried to learn when we was on Form 2, and also for our topic of Newton law and motion that we try to see as the second as the second topic for Form 5. We try to see that if we recall the Newton's second law, which said that the linear the masses must be the force applied must be direct proportion to the product of their mass. It means mass 1 times the acceleration 1. Kwa tukimrecall yule Newton's second law, we should say that the force acting on point A, this force acting on point A must be equals to m1 times a1. Kwa huyu force ambaye ata act kwenye point A hapa, force A, huyu atakuwa ni sasa na kuchukua huyo m1 then we multiply by the acceleration that exact at that point. Kwa sasa na m1 times a1. If we simplify, we know that, my dear students, we obtain this acceleration 1. How can we get the acceleration? So we know that the acceleration must be equals to the radius, then we times by the angular acceleration. Kwa hiyo tuweza kupata sasa yule acceleration wetu ambao ata exact kwenye particle 1, it means kwenye point A atakuwa ni sawasawa na kuchukua yule radius 1 tutazidisha na yule angular accelerations. So here instead of writing a1, we should place r1 and this angular acceleration. This simply represents the angular acceleration. So we can conclude by saying that the force along the point A must be equals to mass 1, and then we times by the radius 1, we times by the angular acceleration. This could be our equation number 71 for our first topic here. So where this alpha here represent the rate of change of the angular the rate of change of the angular velocity. Kwa huyu angular acceleration atajaribu kurepresent ile rate of change of atarepresent the rate of change of the angular velocity. Kwa ndo maana definition yake itakuwa hivyo, kwa sababu utakutana kuambia kwamba how can we obtain the angular acceleration. Mwambie angular acceleration ni sawa na rate of change of the angular velocity, then we divide by the rate of change of the angular velocity upon dw divided by t. And this is the angular acceleration, which is the rate of change. As I told you that the meaning of this alpha is the angular acceleration, which is expressed as the rate of change of w. So that's using equation number 70. As we use our equation number 70, we say that the moment of force au tunaita ni torque on the particle A can be expressed as this one. Kwa tukishaliko sasa equation yetu ya 70, tutasema kwamba kumbe ili tuweze kupata torque au tunaita ni moment of force, tutasema for the particle A atakuwa ni sawa na torque A must be equals to force A we multiply by R1. Ndo formula ya kuweza kupata torque along the point A, ambapo atakuwa ni sawa na force A then we multiply by R1. But we know that we have tried to explain the meaning the formula of this force A, which is equal to m1 r1 times the angular acceleration. Now we should substitute, instead of writing this force A, we should place m1 r1, then we multiply it by the angular acceleration. Kwa ukisubstitute pale utapata ile r1 square. Kumbe sasa in order to get this torque along the point A must be equals to mass 1 times the r1 square, then we times it by the this angular acceleration, where this m1 represent the mass of the particle r1, and also r1 here represent the radius or the distance from the axis of rotation up to the point where the particle A was located, and this alpha here represent the angular acceleration. So that is how we are demonstrating.